Hi everyone. Today we will discuss two complex questions to familiarize you with these types of questions. Now these questions were selected from our past year test. So what are complex questions? These questions are normally indirect questions which requires you to think or to strategize in order to solve the question. The question could also be a combination of more than two chapters. Let's start with the first example. The best way to go about this is to try the questions yourself and then check your answers at the end of the video. Otherwise, you could go through the video once you are stuck. Let's look at this question. It says this figure shows the reaction time in milliseconds of a sample of 30 patients with schizophrenia in a behavioral experiment in the form of an ogive. So this is an ogive, and if, as we have learned in class, the x-axis of an ogive is always the class boundaries, and the y-axis would be the cumulative frequency. Okay, so the question says apply the knowledge you have about ogive and frequency tables to construct a frequency table containing the class boundaries, cumulative frequencies, and frequencies from the ogive. And next, using exclusive class intervals, calculate the mean, variance, and standard deviation. Okay, first things first, there is a mistake in this ogive. Could you detect the mistake? Yes, you're right. Okay, so 600 should never be written at the origin. The graph could have been moved towards the right hand side. Okay, so our task is to construct a frequency table containing the class boundaries. That would be quite easy because the x-axis always contains the upper boundary. So I would start with the upper boundary. So we have 600 here, 700, 8, right? So these are the upper boundaries. And what would be the lower boundaries? If you still remember, the upper boundary of the previous class would be the same as the lower boundary of the next class. So this value would be 600, and the class width is 100. So 700 minus 600, class width is 100, which means this would be 500. Okay, so let's complete the table. This would be 700. So there you go, your class boundaries. Okay, so your y-axis would be the cumulative frequency. So this would be the cumulative frequency. It starts with 0, 2, 9. So we have completed the class boundaries, the cumulative frequencies. The next step is to calculate the frequency, and this would be quite easy. You take the cumulative frequency from the next class minus the cumulative frequency of the previous class. So we always start with 0, and here you have 2, 7, 4, 5, 6, and 6. Okay, so we have done the first part, and it's not that complex actually. On to the next part. Using your exclusive class interval, calculate the mean variance and standard deviation of the reaction time. Okay, so what are the characteristics of an exclusive class interval? The upper limit of the previous class interval would be the same as the lower limit of the next class interval. So in this case, the class boundaries would be similar to the class limits. And the reason that we would like to determine the class limit is because we would like the midpoint, okay, in order to calculate the mean, variance, and standard deviation. Before we calculate the midpoint, let's have a look at your ogive again. Now, if you still remember, when we draw an ogive, we always include an extra class interval. So we do not need this right now. The formula to calculate the midpoint is the upper limit plus the lower limit divided by 2. So we have 700 plus 600 divided by 2, which gives us 650. This would be 750, 850. Okay, so whenever you are asked to calculate the mean, variance, and standard deviation, the first step is always to determine whether your data is a sample data or population data. And in this case, it is a sample data. And to calculate the sample mean, that's quite easy. We simply take the summation of the frequency multiplied with the midpoint divided with the summation of the frequency. So the summation of frequency would be 30. So the sample mean is simply 930. Okay, the next step would be to calculate the variance and the standard deviation. Now, in order to calculate the variance, you would need the frequency multiplied with the square of the midpoint. Okay, you could write it as fm square or m square f. The values are as below. Okay, so the summation of fm square is 26,735,000. So the sample variance would be 26,735,000 minus fm, the whole minus fm square. So that would be minus 27,900 square divided with the summation of f, which is 30, divided with the summation of f minus 1, which is 29. This gives us 27,172.4 4138. Okay, and everyone knows that the standard deviation is simply the square root of your variance. So the answer would be 164.8406. Okay, so this indirect question gives you an ogive and asks you to calculate the mean, variance and standard deviation of a sample data based on an ogive. There are multiple things that could have been asked in this question. Another example is to transform an ogive into a histogram, or to transform an ogive into a polygon. Okay, so you need to be able to truly master the concepts of class boundaries, class limits, ogive, the cumulative frequencies, and once you have the basic concepts, no matter how difficult the question is, you would be able to answer it. Okay, so in this question, you are given a polygon, a frequency polygon, with the frequencies written at each point. And if we still remember, your frequency polygon, your x-axis is always the class midpoint. Okay, so in this question, the measurements of the breaking strength in ounces of a sample of 60 linen threads. Okay, so this is a sample. Your data is a sample data of 60 linen threads shown in the frequency polygon. So based on the frequency polygon, construct a frequency distribution table consisting of all class intervals, frequencies and relative frequencies. Before we start with the frequency distribution table, I would always advise you to write out all the informations that you have from the frequency polygon. So from the frequency polygon, we have the midpoint. Okay, so the first midpoint is 17.45. By the way, could you detect what's the mistake in this frequency polygon? Yes, you're right. We could never leave the frequency polygon hanging like this. We always need to start from 0. Okay, all right. So we have 17.45, 22.45, 27.45, 32.45, and 37.45. Okay, so you need to write out the class intervals. That means you need the class limits, frequencies and relative frequencies. Okay, so the lower limit for the first class is given as 15, and the lower limit for the second class is given as 20. Okay, so how do we determine the upper limit of the first class and the following classes? Perfect, based on the formula. So what is the formula? The midpoint is the lower limit plus the upper limit divided by 2. So here we have 17.45. This would be the lower limit is given as 15. The upper limit is what we want to find, divided by 2. The upper limit is 19.9. Okay, so we have 19.9. And what is the class width? Class width would be 20 minus 15, which is 5. And so the upper limit of the next class would be 24.9. Okay, and the next step is to find the frequencies. We simply copy down the values here. Step would be 3, 15, 24, 12, and 6. So the total frequency is 60. We have the class intervals, the frequencies, and the next step is to calculate the relative frequency. That's quite easy. We simply take the frequency, divide it with the total frequency, and here we have 0.05, 0.25. When we total it up, we should get 1. Okay, so we are done with question A. Let's look at question B. So for question B, you need to find again the mean, variance, and standard deviation. What do we need in order to calculate the mean, standard deviation, and variance for group data? Right, we only need the midpoint and the frequency, and we have both. So I have the confidence that you could answer question B yourself. So you try it out, and I would leave you with the answers. So X bar is 27.7. The sample variance is 26.6314, and finally the standard deviation 5.1606.